Hey you there, do you want to learn about stoichiometry? No, you don't, because nobody does. But you know what you might be more interested in? Crackers, salami, all that good jazz food. Everybody likes food. So today, I'll teach you about some of each. But first off, what even is ideal stoichiometry and all that jazz? Stoichiometry is used to find out how much stuff you have in a reaction, basically. So you can find the mass in grams, or you can find the number of molecules and or elements, which you find you don't count them out all individually because there's going to be like a billion zillion of them. So what you would count them in is this thing called a mole, and basically a mole is just a really big number. It's like 6.02 times 10 to the 23rd power, which is also called Avogadro's number. But we don't really need to know all that because the number in front of the element or molecule, which we also call the coefficient, is just going to be how many moles there are. The reason that this works is because of dimensional analysis, which is a big science word that sounds bad, but really it's just like converting one thing into another thing and then using that to do one thing into another thing. It sounds kind of complicated, but it really isn't. And now this might sound like it's not that useful or anything, but you can use this in real life equations, like if you want to find a molecule or something. But what we're going to use it for now is we're going to use it to show how to make cracker stacks. Oh yeah, baby, with salami. Ooh, sussy. Okay, so what you gotta know basically is for our equation, we have 3 crackers plus 4 salami plus 2 cheese is 1 cracker stack. And remember, the coefficient is just how many moles there are in front of it. So that's why I put all the mole there. So below that we have the molar mass of all the foods, and the molar mass is just how much mass there is in something per a mole of it, so how many grams per mole. So cracker 3.2 grams per mole, salami 4.8 grams per mole, and cheese 16.7 grams per mole. And then just combine all the ingredients, and that's the molar mass of the overall stack. Okay, so ideal stoichiometry is used to find 3 main things: moles to grams, grams to moles, and grams to grams. But let's start with mole to gram. So first off, let's say we're given 6 mole crackers and we're supposed to find how many grams of cracker stack you end up with. Well, the first thing you want to do is you want to get all the amount of crackers you have, or whatever you have in this equation, and figure out how many of that in the equation is equal to however much of what you're finding. So we're going to say we start with 6 mole crackers, and 3 mole crackers is 1 mole of stack, so we'll do that. And then what you want to do is put 1 mole of stack down here, or 1 mole of whatever you're doing, and then put the molar mass of that above here, which, as you remember, is 62.2. So then once you have all that, you just multiply all this together and divide it by here. And so you see 6 of these broken up into 2 groups of 3, the molar mass, and then boom. This is what you would end up with, 124.4 grams a stack. Okay, so now we're going to do grams to mole. And this time, let's say we're given 57.6 grams of salami, and again, we want to find the number of stacks we have. But this time, we want to find the amount of stacks we have, the mole of stacks, and not how many grams of stack we have. So what you got to do is you start with what you're given, 57.6 grams of salami, and then we want to go and do the molar mass of that. So we do 4.8 grams of salami is 1 mole of salami. And then from there, we want to go and do how many of salami is in 1 stack, so how much of one thing makes the other. So we know we need 4 mole of salami that ends up with the product of 1 mole of stack. And so then we multiply this whole top row by each other once we're done again, which is just going to be 57.6, divided by the bottom row, and then we do all that, we're just going to end up with 3. So you see, you get all these and all this, and you got 4 of those in each one, and what we're going to end up with is 3 cracker stacks total. Now we're going to do gram to gram, and the reason I kept gram to gram here is because gram to gram is a lot like gram to mole. So let's say we have 57.6 salami again. What you do, the first steps would all be the same. The only different thing is after you find the mole of stack you have, you would just want to find the molar mass of that. So we'd go 1 mole stack is 62.2 gram stack. And so then again, you multiply all the top by each other, and multiply all and the bottom by each other, and then divide them. And we already know we have 3, so basically what you're just going to get is 3 times 62.2, and that's how many grams of salami you're going to have. So I don't have a weight measure on me right now, so I can't weigh it, but just know that's going to end up being around 186.6 grams. You know, it might be more or less half a gram because not every cracker is going to weigh the same. To get a little more practice with the kind of equations you'll be doing in science and not salami, let's do one more gram to gram, which is, let's say you're given 30 grams of HF. How much SNF2 will you be able to make? We'll just start with 30 grams of HF, and then you want to do the molar mass of that. So 20 grams of HF is 1 mole. And so then you just want to do 2 HF, as you can see here, is going to end up with 1 SNF2. And then you're just going to find, again, the molar mass of that, which is 1 mole as NSF2 is going to be 156.71 grams. And then you multiply all the top, and then multiply all the bottom, and then divide the top over the bottom, and you're going to get 117.5 grams of NSF2. Room changed, we're at my house now. But so yeah, basically, that's all you gotta know about ideal stoichiometry. You can do grams to grams, moles to grams, or grams to moles. And while that sounds like it might just not be useful for anything, you can use that for things like finding out how much salami you'll make. And while that's not super realistic, you're not going to usually measure how much of a salami you have. You know, similar sort of things, like if you're measuring meat at a butcher or something, that might be using that. So yeah, but now that I'm finally done with this, you know what that means. I'm finally done with chemistry. Woo! Here we have your average actual yield fan. As you can see, he's a little tiny baby. He's gonna get all distracted by real life problems and user error versus ideal stoichiometry enjoyer. He's biggie. Boom. Let's go.